Your wrist connects your hand to your forearm. It is not one big joint, it has several small joints. And this makes it flexible and allows you to move your hand in different ways. The wrist has two big forearm bones and eight small bones known as carpals. It also has tendons and ligaments, which are connective tissues. Tendons connect muscles to bones. Ligaments connect bones to each other. Wrist, also called carpus, complex joint between the five metacarpal bones of the hand, radius, ulna bones, and forearm. The wrist is composed of 8 or 9 small short bones, carpal bones, roughly arranged in 2 rows. The wrist is also made up of several component joints. The distal radioulnar joint, which acts as a pivot for the forearm bones. The radiocarpal joint between the radius and the first row of carpal bones, involved in wrist flex and extension. The midcarpal joint between 2 of the rows of carpal bones, and various intercarpal joints between adjacent carpal bones within the rows. The numerous bones and their complex articulations give the wrist its flexibility and wide range of motion. A disc of fibrous cartilage between the radius and the ulna separates the radioulnar joint from the rest of the wrist, which is contained within a capsule of cartilage, synovial membrane, and ligaments. Radiocarpal ligaments carry the hand along with the forearm, and rotational movements of intercarpal ligaments strengthen the small wrist bones. The large number of bones in the wrist force blood vessels and nerves in the area to pass through a narrow opening, the carpal tunnel. In carpal tunnel syndrome, a narrowing of this opening painfully compresses the nerves during wrist flex. Other common wrist problems include bone fractures, dislocations of the various component joints, and inflamed tendons and ligaments from overuse. Hand, grasping organ at the end of the forelimb of certain vertebrates that exhibits great mobility and flexibility in the digits and is in the whole organ. It is made up of the wrist joint, the carpal bones, the metacarpal bones, and the phalanges. The digits include a medial thumb when viewed with the palm down, containing 2 phalanges, and 4 fingers, each containing 3 phalanges. The major function of the hand in all vertebrates except human beings is locomotion. Bipedal locomotion in humans frees the hands for a large manipulative function. In primates, the tips of the fingers are covered by fingernails, a specialization that improves manipulation. The palms and undersides of the fingers are marked by creases and covered by ridges called palm prints and fingerprints, which function to improve tactile sensitivity and grip. The friction ridges are arranged in general patterns that are particular to each species and that differ in detail. No 2 individuals are alike, and in humans the patterns are used for identification. The thumb is usually set at an angle distinct from other digits. In humans and the great apes, it rotates at the carpometacarpal joint and is therefore opposable to the other fingers and may be used in combination with them to pick up small objects. Among the apes and some New World monkeys, the hand is specialized for brachiation, hand over hand swinging through the trees. Digits 2 to 5 are elongated and used in clasping tree limbs. The thumb is reduced and little used in swinging. Terrestrial monkeys, such as the baboon, do not have reduced thumbs and can carry out precise movements with fingers and opposing thumbs. The development of dexterity in the hands and increase in brain size are believed to have occurred together in the evolution of humans.
In detail. No 2 individuals are alike, and the humans of the pattern.
Why hands? Human hands provide a rich source of information about physical manipulation. However, extracting information about the mechanisms of the hand requires persistent and diligent observation. Thus, automating the visual inspection of the hand interactions will facilitate large-scale analysis and has the potential for significant impact in multiple disciplines. To this day, robotics researchers painstakingly analyze hours of hand-object interactions, manually categorizing and labeling hand use because of the benefits it brings to understanding robotic arm design and many other disciplines.
Terrestrial monkeys such as baboon do not have reduced thumbs and can carry out precise movements with fingers and opposing thumbs. The development of dexterity in the hands and increase the brain size